that immersion will be sometimes that I just show up here and just show specific videos because I want us to kind of get comfortable with being around, the content. For some of you that haven't coded before, one of the first things you're going to notice is all of a sudden you're looking at code. It doesn't look very strange anymore to you. And as you keep doing that, before you know what's happening, you are going to just get very comfortable with it. And then first you begin to know how to like read code, and then you begin to write your own code. So these are some of the things that are very important. So like I mentioned, I'm going to run through what we did last week. Then we're going to go into unit 2, which is algorithms, and I'm going to give us an introduction to algorithms. I'm not sure we're going to go too far into algorithms. And all of this, right? All of these are around Swift. Remember everything we are doing in this class is Swift, which is the language, and Swift UI, which is the interface builder, right? You use Swift UI to build the interface. What runs in the background is Swift. So what I've been doing is to get everybody comfortable that you did. I'm thinking I want to run some videos so that you can again watch how that process happens from beginning to creating your very first app. Because I know there are people asking, oh, when are we going to start creating apps? If you haven't started, it's very important that you start immediately.
Yeah.
I'm going to run through one of those today.
I just went to my pull up.
How do I mute? Okay, so that's what we're going to be doing today. So I'm going to just quickly open up my slide for what we did last week, and then I'm going to share it. I'm going to do a quick run through of what we did last week, and we will go from there. So I would say I will share my entire screen. Right, so just a minute. So this is a bit of what we did last week, and I'm going to go back to the beginning, right? Where essentially this is exactly what we did. Started with Swift, talk to us about Swift, and this is all we are doing. The class you are attending right now is developing in Swift explorations, which is the first part. So you have explorations, fundamentals, and data collections. Our focus right now is explorations, and we're in chapter 1. And then we talked about values, right? I talked to us about programming and how it's important that you understand that programming is essentially all about data, all kinds of data, visual data, tactile data, text, voice, all of that is data. You put them through some kind of program, right, as inputs, and then the computer gives you some kind of output. And so our focus, right, in doing all of the programming stuff would be around creating programs. And then I did mention that in a lot of programs, there are ways programs, right? C++, C, C Sharp, Python, and all of them. They all have a way of expressing and manipulating data, and Swift is not left out. For most of, there's a lot of similarity between a lot of the programs, but there are slight differences in some of those programs. And so when you try to transition from one program to the other, sometimes you notice some differences. So after that, one of the things I did mention was that name media, for example, Nadia is just a name. Nobody goes around to say Nadia, 5'6", blah blah blah. You don't talk about all the characteristics and features around her. You just say Nadia, right? But that's one word, Nadia, right? Has a whole lot of things behind it. In computer speak, you could literally have Nadia, and then there's a clickable link. Once you click it, it now opens up all the information about Nadia. That ability to be able to hide other details, right, about Nadia is what you call abstraction. And as you do programming, you're always going to bump into this whole idea of abstraction. Then we talked about identifiers, and I said it was really very important that when you name things, that you're very clear about those names, the names that you give to things, because it makes it possible, makes reading your code very possible. It makes it possible for you to come back many years and still understand what you did right, because people literally write codes, they come back and they can't understand what they were doing. So two ways, right, very good programmers use in making sure they understand what's going on is making sure they give good names, very clear and descriptive names, right, to objects, things, people, all of that stuff, right, that you have, variables and constants. You give very clear and descriptive names to them. And, this whole thing, these names, we literally, agreed in the last class that they are called identifiers. So like I was mentioning, good programmers do two things, right? They write very good, they use very good identifiers when they want to name things. And then the second thing is that they write a lot of comments. And comments are, some kind of description or explanation of what you're doing within your code that the computer or the processor really doesn't need to see. And we're going to see some of that if you're not familiar with comments already. So we now agree that naming is a very important skill in programming, and good programmers are actually good at creating very good identifiers. I already mentioned why it's important for you to have very good identifiers. And then we talked about the convention, talked about the Pascal case and the Camel case. Pascal case is literally where you have, okay, look at this word, event handler. The first letter of the first word is a capital. The second letter of the second word is a capital. That's an example of where you're using uppercase, camel case. And when you have uppercase, camel case, you actually refer to that as Pascal case. And then you have the actual proper camel case, which is where you're using lowercase camel case, which is literally that whatever first word you're using, right, the first letter of that word is a lowercase, as in this case, and then subsequent words that would be attached along with those words would be the first letters of those words are capital letters. And then I did mention that there's no accommodation in naming for things like full stop, gaps, and all of that. No, for this specific convention, all you have to do is just make sure if you're putting two or three words together, make sure the first word, lowercase, others, first letter of subsequent words are uppercase. And then we kind of showed some examples of this. So speed of car, it's very easy. Right, if I wrote this code and you saw this, you immediately saw that whatever followed equals to is talking about the speed of a car. Height of a building or height of building, you automatically know it's height of some kind of building. Annual profit, it's easy for you to be able to know. So if you haven't been around code before, I'm sure when you saw things like this, you were wondering what exactly is going on. This is what exactly is going on. So after that, we now talked about how we make a sharp distinction between two kinds of words, make a sharp distinction around a lot of things, data types that we're going to meet, and we divide them into two broad classifications, like they are constants and variables. And at every point when they come into existence, it's very important. It's almost like when you are born and then you are assigned a gender. At that point, it's very important to assign you a gender for very many reasons. One of which is legal reasons, and then there are other cultural reasons, why you have to assign a child a gender at birth. Same thing when you bring some kind of identifier into existence. You want to be able to assign them, some kind of quote unquote, right, gender, which is like it's either a constant or a variable. And then we went ahead and I gave us examples of things, examples of constants. Pi is never going to change. That's always a constant. But what you're going to have for dinner is going to change. Your place of work most likely might change, right? Your height will change over time. Your weight will change over time. Things like your skin color, it's unlikely those things will change. Your date of birth, change in itself, right? Is not constant. So change doesn't change. If you could assign a value to it, it's going to be a constant. So we pivoted from that and we went to talk about different kinds of different kinds of data types. And why I'm taking the time to go through all of this is because I'm trying to make sure I reinforce this knowledge, because like I mentioned, these are like the ABC of programming. Once you can get them right and you understand them and you're comfortable with them, it makes your journey later actually very easy. So as we do a lot of these repetitions, we just end up with a situation where we are creating neural pathways in your brain that make these things like become a part of who you are. So Swift, but for Swift, there are 6 main data types. And one of them, we mentioned 6 of them. One of them is character, string, integer, float, double, and bool or boolean. And I showed us different examples of each of these data types, right? Character, string, integer, floats, and what the differences were. Character is literally one letter of example, the alphabet, for example, right? And it's not just the alphabet. There are other things like I could have 6 or 7, right, as a character. Now, I could have an art sign. I could have an emoji, right, as a character. All of those things, provided it's just one letter, it's a character. And then we talk about strings. When you combine a number of characters together, that's when you get a string. And notice how you put in quotation marks everything around characters and strings. That's just how they are. So, and then we move to integer. Integer has to do with everything on the number line that's a whole number, whether it's on the negative side of the number line or on the positive side of the number line. Minus 1,000 is an integer. 1,100 is an integer. And then we go into float, and that's when you begin to introduce, decimal points, fractionals, right? And I said floats and doubles are very similar. The only thing is that doubles are able to accommodate more, fractionals behind them, like up to 15 decimal numbers. That's the major difference between both of them. And Booleans are literally on, off, 0, 1, true or false. They are usually used to try to understand, make decisions and all of that. And you're going to see their use as we continue in the class. So I'm not going to bore us with all of this. I need you to make sure, for example, you stumble on this, try to type it up. I actually have the code because I developed some of this code, but I wouldn't want to give them to you, because one of the things that would actually help you is looking at these things the way they are, typing them out, right? It gradually begins to become part of who you are. And it strengthens your ability to be able to read through code, understand code, and do all. So if I were you, what I would really do is, as I go through these slides, I type out these codes in, in your console, try to run them and see what results they give you. So I talked about strings, string literals, and how to create them. And these were specific examples that we talked about, string interpolations. And if you have any questions about any of this, please talk to me, or you can actually ask some of those questions. I know I'm owing one person that sent me an email. It's been a very busy week. I haven't been able to get back to you on that. Please just bear with me. I will be back with you on that. So these are all examples of the different data types, and that was essentially what we did last week. So I want to open it up for questions. Should you have any questions? Does anyone have any questions with what we did last week? I will be very happy to talk to us, about that. Does anyone have any specific questions? Because if there are no questions, I would be happy to jump into the second slide, where we actually now pivot from just your data, your value, and we go into algorithms. Now you're beginning to build a machine, right? That carries that data and transports the data to begin to produce some kind of results. And then when I go through that, we're not going to be able to cover all of that today, but I'm going to get to an extent, and then we will go back to the videos to actually now go look at the videos of that would help us and that would help with the app. If you noticed in Unit 1, there was a specific app about a photo frame. We're going to go through that's procedurally step by step. And if you want to get your Xcode set up and probably have your book opened, that questions? So, and what we had for, and what I'm referring to here is actually what I'm referring.
It's freezing. I can tell we got the connection's good because I'm running speed tests.
Sorry, guys. I'm trying to mute. This fellow. Okay. So, so I was referring to the Swift UI exercise. It's literally in your book, and there are also a couple of videos, very short videos that actually show you exactly what to do. So the goal is for you to be able to practice and begin to build. It's a very simple app. All it does is creates the interface and puts a picture there. So I'm going to walk us through the video, and then I would also hopefully be on Xcode in case you want to follow the process. And if there are questions, we can address that, because we're already moving to Unit 2, and I want to make sure at least we touch the Swift UI part of Unit 1 before we go into Unit 2. Because what we have in Unit 1 is actually going to build into building a more sophisticated app at the end of Unit 2. So I want to make sure everyone is comfortable with being able to build, the static app. I would say it's a very basic app right now. So any questions? You can just speak up, raise your hand, whatever works for you. Let me see the chat area if there's anything. I can't hear you. Okay, fixed. Comes around is going to tell us a little more about those exams and the logistics for those exams. So I'm going to pivot right now and move to the second slide if we don't have any questions. So just give me a minute. Okay. So I'm going to be sharing my screen. Or rather, let me share this unit 2. Okay, so this is unit 2. Just a minute. And this is where we are right now. We dealt with unit 1 and we are looking at algorithms, and algorithms will start in your book. I think, let me see. I'm scrolling through the book. That would be somewhere. There are some parts of the book I haven't touched in unit 1, and I deliberately left those out, and those have to do with the whole process, the non-coding part of developing an app. I'm going to spend some time in the future focusing on that, so that, because most of the work you do in developing an app is not necessarily writing the code. You're going to be doing a lot of ideation, gather your ideas, and then you build like wireframes, and then you build high fidelity examples of your app before you actually go into coding. So some of those things we are going to be talking about later. I'm actually literally just leaving them, but I hope you have been able to read all of those. But we will come back to those. I just want us to focus on this first. So literally, I'm right now on page 107 of the book. And I'm going to be touching on a number of things. And these are like some of the key foci of this unit. And they include learn how to analyze problems and create algorithms to solve them. So for the non-technical folks in here, you're going to first of all understand what an algorithm is and how you move from your problem to algorithms, and then to solving those problems before you write your code. And then number 2, you want to be able to know how to express your algorithm in plain English, and then create codes with the help of your pseudocodes. Now, when you write out your algorithm, right, in plain English, right, they are called pseudocodes, because they are like codes, but they are not real codes. They are just plain English. And then once you have that plain English, you can now begin to write, the code over the pseudocode, which is like what we mean here, creates the codes with the help of your pseudocode. So this is mostly computer science. And then eventually, we're going to understand what functions are, and how to, and what they do, and how to create them. And then we'll see how you can actually incorporate decision making using control elements like if else. In the future, we're going to go into while loops and all of that. But for this chapter, the main focus is going to be like literally using if else statements to be able to solve those problems. And then eventually, which is what I mentioned, that's why you need to get comfortable with starting to build the app right now, because eventually, in fact, if you look at the syllabus I sent out to you, you find out that at the later sections of this class, those later sections will be very heavy on app creation. So what we are doing right now is just laying the groundwork and also helping you to build some static, very simple apps. But if you miss the building of the simple apps now, by the time we get to those points, you're going to get confused. So that's why I seriously emphasize, try to go look at those exercises. Page 48 is where we had the first Swift UI app, or the first static app. Try to work on that, because we are very quickly going to bump into the dancing boogie board and the data analyzer app, and where it's all going to be based on all of the knowledge we already gathered from this unit. So very simplistic, because I know there are people that have a very strong background in computer science, programming, and all of that. But like I said before, I need to indulge your ask for your patience, right? Because we have a whole swath of participants also that have no background. So we're going to be doing that yin yang. And for others that have some experience, but they are not exactly sure what these things are, this is an opportunity for you to also get a little comfortable. So remember the last time when I showed us in Unit 1, right, inputs and outputs, there was something I put here and I said it was the program. Now, the heart or the engine or the skeleton of the program is actually what you call an algorithm. And you're going to see that even though it sounds very kind of esoteric, right? An algorithm is very simple. It's something you already use every day in your life in making decisions, right? So what exactly is an algorithm? Just look at this: a finite set of clear instructions that can be performed in a prescribed sequence to achieve a given goal. So you wake up in the morning and, someone bumps into you and is asking you, so where is the registrar's office, right? And then you begin to give them a description, right? That description you're giving them is literally an algorithm. And that's how a lot of the programs we write, they are based on algorithms. Now, the only way computers in and of themselves are not intelligent. The only way you can make them do intelligent things, right, is by giving them very clear instructions. And that's where algorithms become very important, because now, and your ability to be able to write a meaningful program comes down to your ability to be able to develop very clear instructions, so that when a computer sees this, as dumb as the computer is, the computer is able to execute those instructions. Now, for those of you that are going to be writing like the certification exam, I would think things like this, like what's an algorithm, things like that are going to begin to feature, right? And then you're going to see, you might run into things like the 3 essential building blocks of an algorithm. Now, a typical algorithm has a list or a sequence of instructions, which is what I already mentioned, right? But then the 3 key building blocks of every algorithm is sequencing, which is literally the arrangement of the instructions, right? Now, and I'm going to show us an example with like what you have on your GPS or Google Map. And you see like how important, arranging these things in the right order helps you get to your destination. Now, the second IE, sequencing, literally means how you arrange those instructions. Algorithm are a set of instructions. Sequencing, which is one of the characteristics of algorithms, is how you actually arrange those sequences. Then we have the second thing that's called selection. Now, selection literally enables multiple paths through an algorithm, and I'm going to explain what that is with a diagram. Now, it makes it possible to interfere with the natural sequence of a code, which is top down, and I'm explaining what that is in a jiffy. It helps with modeling decision making. Now, selection. In Swift, as is the case in a number of other programs, right? When you have a line of code, let's say you have 500 lines of code, right? And you begin to execute those codes. Typically, the codes begin to run from top to bottom. So that's the natural sequence of a code. Normally you have lines. You have line 1, 2, 3, 4, 5, 6 until you have line 50. Once you have your cursor or something at line 1 and you click to execute or to run, the code runs from 1 to 50 and then it stops. Now, there are other things you can do to make that code loop. like get to 50, go back to 1, or get to 50, go back to 30, and run down, go back. And that's where we probably go into things like iteration and all of that. But for selection, I'm trying to explain what selection is all about. Now, selection is literally that attribute or that action, right, that derails the code from running from top to bottom. For example, it makes it, let me show you this, I think something like this. Let's say this is a set of instructions, and this is supposed to run this way, right? Is she an authorized user? Let's say we just say she wants access, right? In a straight line, it will be she wants access, access granted, you fetch the file, and then you transfer the file to her, boom. But then selection is literally what breaks up that line of action, right? Where you now have to make a decision such that you're either going left or you're going right. That's selection. So it creates an opportunity for branching out from the normal course of direction of your code. So that's a characteristic of one characteristic of algorithms. So a lot of algorithms are written in such a way where you can now begin to make decisions, in multiple ways. And I'm going to show you a couple of other things to show how all of that works. So in this case, I want to be able to check and see that she's an authorized user before I can grant her access. So I say, maybe it's Mary. Is Mary an authorized user? And then the system has to go check against maybe a file or something, and then says yes. If it's yes, then you grant her access. After you've granted her access, the next instruction or line of code, right, is fetch the file. It gets the file from somewhere, and then it transfers the file to Mary. If the answer is no after the system has checked, no, and then it automatically denies access. So all of this is not executed. That's an example of selection. And then, of course, iteration. I think iteration should be in Unit 3, where we're now beginning to talk about sometimes there's a need for your code to loop around, go round and round and round for some reason. Maybe you want it to run a certain number of times before it stops. Do something while something is true. That's iteration. So the 3 essential building blocks of an algorithm are sequencing, selection, and iteration. So I did mention this, that codes typically run top down and then they stop on the last line. And then selection is literally what you use to be able to alter that natural path of a code. So how do we, the next slides, we'll be talking about how to actually analyze problems and create an algorithm to solve them. Our focus, as it were, of the 3 essential building blocks, our focus today is going to literally be on selection, how you branch out those parts in an algorithm. So I think when I was making this slide this afternoon, one of the things I tried to do was, I'm like, okay, let me just go to Google and grab the direction from Columbia to Camden, right? And then I see something like this, right? So this right here, right, is an algorithm, right? It's a set of instructions line by line that tells you what to do. And it has to be done in a specific sequence. So if I decide, this is just 79 feet, I want to tackle the more, longer miles, and I shift this here and I move this here, guess what? I'm not going to get to my destination because it automatically alters my path. So that's where sequencing becomes very important. It's very, very important that we arrange the code in the sequence that makes sense and gets us to where we are going to. And what you have here, right, might just be what I'm going to show us, which is like a pseudocode. It's not the code itself. The code is written somewhere under the hood, right? But this is some kind of pseudocode, right? In plain English that tells you turn right on Laurel Street, drive for this number of miles or this number of feet, turn this way, turn this way. With this, you can actually begin to build a program, right? That you can now implant in your vehicle. And whenever you click Camden, Columbia to Camden, the car will just follow those instructions and take you straight to Camden. But this is the pseudocode that you need to be able to write that program. So I try to trace that path. It's like turn right. Now this is not to scale, but I was just trying to illustrate something. 79 feet, then I do 30 feet right, and I do 0.2 feet left, and then I come this way, and then I go this way, I go this way, I go this way, and then I end up somewhere here, right? Now notice this is complete. Both of them are the same thing, right? But they are different. So this is what you would literally call like your pseudocode, and this is a little bit like your flow diagram. And I'm going to show us the standard flow diagram and how all of that, right? How you move from your pseudocode to your flow diagram, and then from your flow diagram to your program actually. So this is a set of instructions that can actually help you sum up the two numbers, right? You have two numbers in mind, and you're trying to sum those two numbers or to add them up, right? So what would be a set of reasonable instructions, right, that I can use to sum up these numbers? I'll say start the program. Then I will at least declare or read in the first number, right? And then I'll save it in a variable. Remember the variables we talked about last class, where you create a variable, right? So we read in that variable, and it doesn't have to be a variable if you're focusing on a specific number, but if as like every other code, because it's going to be reusable, you want to use different numbers in the this. So start the program, reading the first number, reading the second number, right? Add up the two numbers, right? You know, which is, let's say its sum is equals to x plus y. So you've declared x, you've declared y, x plus y, and then you print out that sum, right? So this is a pseudocode. You know, a more sophisticated way of writing a pseudocode could be something like this, right? If you're getting comfortable with programming, you can write something like begin, read x, and then read in x, read in y, and then you compute sum equals to x plus y. Then you print the variable, which is your sum that came up here, and then you end it here. So in some of the programs that you might need to write in the future for it to make sense, this would be a way to start. And then you see people just go in there and start writing things, right? They've been through this over and over again. So at the end of this, it's about your thought process, the way you think about all of these things. But then this kind of helps to begin to, you know, train your mind on how to think about problems as you run into them. I haven't spoken about the pseudocode. Now, once you have a pseudocode, right, people sometimes from the pseudocode now develop like a flow diagram. And in computer science, for those of you that have been around computer science or taking those courses, this would be familiar to you, right? Where you have a bunch of symbols that are used to develop your flow, what do you call it? Your flow diagram or your flow chart. Now, when you see this symbol, it's kind of start or stop, and you're going to see its use. This is for compute. They have specific uses, and you can see all of that here, but I won't dwell on this because the slide is going to be available to you. So we can proceed. So this is an example of the code, and this is actually the code we got here, right, of adding two numbers. Then I move in here and I say begin. So, and I use this symbol, right, because it's usually for the beginning and the ending. And then this is usually when I'm trying to do some kind of computational work, right? And I use read. You know, I'm reading in those two numbers, X and Y. And this is where you perform an operation, right? And then that's my X or Y. Then I print and then I end. Typical flow chart. So sometimes you want to do this. I remember when I was talking about the design, when we come to, you know, designing your app, the wireframes, the high fidelity document and all of that, these are all things you need to do on paper before you start to code. Some of the things you might want to achieve in the hood of your app, you might find yourself in a situation where, like, if you just go straight to try to write some of those things, they wouldn't make sense until you sat down to actually flesh things out on paper and see how everything connects and everything works with everything. So this is another, you know, another problem, right? Where I want to introduce my if-else statement. Remember how we used if-else, right? I didn't just want to give Mary access to those files. I wanted to test a proposition and be sure that Mary is an authorized user. So because I'm trying to figure out if Mary is an authorized user, I want to be able to introduce an if-else statement. So how do I want to do this now? This is also two numbers, but I'm trying to literally, you know, have different operations happen under different conditions, right? So I'm saying today is going to be Monday. If it rains, don't go to work. If it doesn't rain, go to work. Now, if I don't go to work, what should I do? Then go grocery shopping, right? So you're just creating a bunch of these decisions that have to be made. But how do you actually flesh it out so that it now makes it easy for you to write a code? So if I start here and I narrow this down here, it's very easy for me to all of a sudden begin to write the codes that I showed you last week, because every line can literally form something, right? So an if-else statement is one whole thing, right? So beginning here, I can literally write that. I can read in, this is where I have my var or my let this equals to this, blah, blah, blah. And then I come in here and I have my printing. But being able to write that code is possible because I've been able to go through the process of thinking through what needs to be done. So I start the program. I read in the first number and I save it as a variable X, right? Reading the second number, saving as a variable Y. If the first number is greater or equal to the second number, right? Now in this case, my first number is X. My second number is Y. So it should read something like, if X is greater or equal to Y, subtract 2 from X and save the result as a variable called output, right? And then otherwise, another way of saying else, subtract the first number from the second number and save in a variable called output. But that's your thought process. As a human, if I'm going to solve this problem, what will be my thought process? I want to be able to put it down line by line. And then I move in here, right? Begin. And then I read my X and my Y, and then I look at what I've actually said here, which is literally if X is greater than or equal to Y, then output this, else output is equals to this. Then you print your output and then you end. How do I want to represent that? And I copy all of that here. How do I want to represent that in a flow chart? It's going to be something like this. Same thing, very, very straightforward. You usually start with your start and your end. I want to input something. Anytime I want to input something, I use a parallelogram. I want to output something. So for inputs and outputs, I use my parallelogram. If I want to make a decision, I use this. So it's true, my output will be x minus 2. If it's false, my output will be y minus x. And then I store my results, I print, and I end. Any questions though? So even though we're not talking about loops and all of that, this is another example, like literally where, for example, I take in something, right? My I, for example, is maybe like a counter, right? I want to run this thing a number of times. Let's say my I is equals to 5. I want to run this instruction 5 times, or I want to perform this operation 5 times. And I start with a sum 0, right? And I start running. While I, which is my count, right? If it's greater than 0, true, I read in, I input my value, I sum x plus a certain sum, then I increment my counter from 0 to 1, and then I keep going there. If my I is equals to 5, right? By the time I get to 5, right, my I is greater than, say, is greater than 5, or let's say it's now 6, then it's false, and then it moves, averages, and it sorts all of that out. But a more practical example, which will make sense for us, I'm trying to write something, right? I'm developing an app, and my goal is to be able to, even, I picked this online, right? This is Facebook. I start and I log into Facebook. I've been able to log in. I get to the home page, right? Now, something I need to do, I need to input some kind of data into the system. Remember, this is your sign for input. And then all of a sudden, I enter my email ID, and then I enter my password, right? Now, notice a decision point comes. Is my email ID or password, are they both correct? If they are not correct, boom, I go back here, I've logged an error. Let's assume when you are writing this code, which is your I, your counter, you're like, if this guy logs in like 5 times, right, then I'm going to log them out, right? So that's how I count. I could literally be like, after I've run through this a number of times, I have another decision point where I'm like, no, lock out the account. But put together all of this. So, which now takes us to the functions, because a lot of these things are actually what you have in unit 2 of that note. Again, the focus of that book is being able to give you, requisite background in a lot of what you need to be able to develop apps, more confidently in the future. So sometimes you write a bunch of codes and then you run into a situation where you're finding yourself repeat things over and over again. So every morning, right? When you wake up, one of the things you do is you take a shower and you eat a breakfast, So those things happen over and over and over and over again. Instead of following those instructions every day, over and over, is there a way I can literally write a chunk of code where I don't have to go through, use a sheet to look at those instructions? Once it's time to eat, I just go press a button and a shower takes place. I press another button, so it's a reusable code. Since I know I'm going to use it over and over and over again, that's literally what a function is. So you have this long code, right? And all of a sudden, I want to be able to put some of those similar actions, right? Or what you call subprograms. Some applications, some programming languages calls a function a procedure program that you can actually keep somewhere in the folder outside your, either within or outside your main code, and you can literally call it anytime you want. Right? So it's a self-contained block of code used to perform a specific function. It can be called and reused multiple times. So when it's literally a way of breaking problems down into logical chunks so that you can solve them independently, so that you don't have this huge, and as we begin to go through code, I'm just trying to open us to this. We'll be able to see how we can literally look at some activities that we know are going to be reused many times and just put them together, and then create a function around them. So eventually, one of the things that happens, characteristics of the functions, is you can now actually combine those functions, right, in trying to solve a bigger problem. I'm going to skip some of this and show us this. So how do you literally create functions in Swift, right? So one of the things, I don't know, I hope I did mention this, is there are some, I think I mentioned that in the first class. There are certain keywords, right, that are reserved. It's like you get into a parking lot and there are certain spots where you actually can't park. If you try to park there, you're going to be told. You're going to be fined. There are certain words, right, that are reserved and you can't use them. You can see return, reserved, func, reserved. But func is literally any time and every time you see func in Swift, it's literally a way of declaring, hey, I'm about to write a function, right? And whatever you have here, this can be anything. You can use anything, right? For your function name. This is the name of the function you're trying to create. So for example, where do I have an example? So look at print, right? For those of you that have been working on your exercises, you would have run into print so many times, right? And then you put in something here and then all of a sudden it prints. This is actually an example of a function, because your ability to print out whatever it is you've done, right, doesn't happen because of one line. It's multiple lines of code, right, which have been saved together as a function, right? And this is a function that was created by those that created Swift, and through abstraction, they've hidden away all the other code from us. So anytime you type in like your print, open and close brackets, all you're literally doing is what we call a function call, right? You're calling on that piece of code in the hood of Swift to please perform that operation. So literally that's what you want to do in your own code. So this is something that has been created by the original creators of the language. Now we can also create our own functions, and that's what's happening here. And what we have here is literally how you create that, right? So essentially what we are doing here is, first of all, this is the keyword that's used to create a function. You can use whatever word you want to use here, something very descriptive, of course, so that it helps you. For example, in print, they decided to use print because they know everybody's going to understand what print is, right? So in this case, this is an example, one example we're going to come back to. I'm trying to add two things here, right? And I use the keyword add. I could have used any other thing, but with add, or I write addition, yeah, immediately it jumps at you. Oh, this has to do with maybe adding something. So function, that's my word. And then these are what we call parameters, right? So the parameters would be like placeholders, right, for the input that you want to feed into. So usually you have parameters and arguments, right? So your arguments, right, like feed into, and I'm going to show us examples, but just for now, just take this to mean these are the parameters, you know, more like placeholders for receiving the input, right? And then particularly for Swift, not exactly the same way in all other programs. Once you write a parameter here, you want to also declare the type of that parameter. You're going to see an example and it will make it clearer. So you declare another parameter, and you can declare 1,000 parameters or no parameter at all. I mean, as you begin to use this, you're going to see different examples of how it can be used. But generally, this is what you have. You have a parameter, and then you declare the type. And when we're talking about, I'm talking of the data type. You know, we talked about string, double, bool, all of that, right? So you declare the parameter, and then the type, parameter type, parameter type. So it's the same thing. Everything I'm talking about here, we just stretched it out. And then after that, you include what looks like an arrow here, which is like a straight line and a greater than equal sign. And then you choose what your return type is going to be, right? And then open and close brackets. And then whatever action you're going to take is going to be here. And then you're going to return some kind of results, right? That's like the syntax, overall syntax for doing that. Next thing is that I'm actually now going to show an example. But then, so if I want to call this function, all I need to do is come here. Remember the print, and you write some kind of print. Notice what's happening with print, right? These are literally like arguments or your input that you're going to feed in here, right? Your value. But specifically for print, for Swift, you want to go again, type the parameter you have, and then enter the value of that part of the parameter, which is more like, I think, your argument, and you do the same thing. And once you do that, this is going to feed that information into this. The action is performed, and you get some kind of output. So this is a very simple example of what I'm talking about in creating your functions, right? And when you go home, you'll be experienced that you try this. So just like the example of the, summing two numbers that I showed, the pseudocode and the flow chart, what you have here is, this is your parameter. So we've chosen a parameter X, right? First of all, we have a username, your keyword, that helps you declare function. So what we're doing is a function declaration. So, but what's the name of that function? The name of the function is add, right? So I've put in the name of the function add. Then next thing is I want to be able to put in my parameters. Remember what we talked about here, parameters? Five other parameters with their types, but here it's just two. So I put it, and then this is the output. The output type, return type I'm interested in, right? An integer. Then I said, this is the operation I want to perform. You can perform all kinds of operations, right? Let sum equals to x plus y, and then I return sum, right? So this machine, right, when it performs, you fed it in with this information, it performs these actions, is going to return some kind of value. So for me to call that's that result, I use what we call like a function call. I can literally decide, you know what, and what you do with a function call is literally you're calling, notice this, add, same thing here. Look at what you're doing. You're just picking this minus the function, pick this, boom, bring it in here, right? And in place of the types, just enter the values, and then you have made a call, right? So here, we decided to, ordinarily, you don't even have to include let sum equals to this. I just included let sum 1 equals to this because I wanted to also make another function call where I get to print this out so that we see exactly what has happened, so that 2 plus 6, for example, is 8, plus 2 is 5, right? So essentially, what's the most important thing you need to do is just write add, open your X, and then you enter the value Y, boom. So once this is done, I can literally put this in a completely different sheet and put it in the folder of the main program, right? Anytime I want to call this program, all I need to do is just write, just like I write my print, I just write add X, and then I enter whatever it is, those values immediately. I don't have to have this code within my main code, or I could have that main code, my function within the code, but only once. And every other time I need to do that operation, I just do a call to that function and I get the results. So that's one of those examples that for those of you that have gone through the tech, read through the book already, it will talk about functions and all of that. So this is another example, right, where I'm literally trying to calculate the volume of a cuboid, right? So X, and then I declare the type. Y, I declare the type. Z, I declare the, why do I have X, Y, Z? Because to get the volume of my cuboid, maybe I've determined mathematically that it's going to be X, Y, Z, right? X times Y times Z, which are the three important dimensions of the cuboid. So through that operation, I know all I need to do is calculate this, right? But I don't want to calculate it once. I want to be able to build a program where anybody can just come enter any number once they know what those parameters are, and then it will give me some kind of result. Boom. So I do that. Why am I using floats? Because all of a sudden, these things are not integers. They're not whole numbers. I have decimal points. That's why I'm choosing floats, right? I do that same thing. I want my result back in floats. Boom, return X, Y, Z. That's the result I want back, right? And then I say, let's volume 1. Volume 1, like, so these are 3 different instances, or three different measurements for 3 different cuboids. I could literally just do the first one and not include all of this, right? And I can get the result. But if I want to print out that result, right, I need to be able to assign it to something, and that's why you have the volume 1, volume 2, and volume 3. Then I print out the volume 1, volume 2, and volume 3, and I get the result. Sorry, I didn't include the results here, but you can try to run this and see what results you get. And once you go on your computer playground, type in this, follow exact instructions, you get the result, and you have created a function. So a couple of other things. I think that's where we will stop for today. For this, I'm going to continue with the algorithms next week, and hopefully we'll finish with the algorithms next week, and then hopefully begin to work on those apps to see how you integrate those apps. Again, a lot of what you need to know in terms of the practice are already in the files that I sent to you. Remember the playground files? For each unit, there are a bunch of files. Go read through the material, open those files, practice with them, because some of the things I'm talking about, declaration of functions, it will give you actual exercises that you can practice with. You have any problems, revert back to me, and I'll try to solve the problem. If I can't, I'll look for people that are better than me, and then they try to solve the problem, and somehow we just keep helping each other, and hopefully we get better with this thing. So questions? Questions? No? Yes? Okay. So no questions. So I'm gonna now go ahead and have us, if you want to open up your Xcode, that will be fine. If you want to follow on with the process, if you hit a roadblock and you need some help, I can, help with that too while I'm here. But let's just go through a bit of that right now. I'm going to just run a couple of 4 videos, actually 4 short videos that walk us through the process step by step. But whatever I have, which I'm going to show you, is already what you have in page 48 of your slide. But I just want to have you see it play out in action. And hopefully you don't do it once, do it a couple of times so that you get comfortable with where all the buttons are on Xcode and what you need to be doing and what things do. That would be very helpful. Questions?